Let's start with the simple kit, or what we call the Smart Citizen kit or the basic kit, and see what's inside. The basic kit is composed of these three basic components. From the left to right, we have a data board, which is an electronics board that we call, that's basically the brain of the kit, that takes care of measurements, taking readings, logging data, handling power and user interaction. In the middle, we have what we call the urban board, which contains a selection of very low cost sensors for environmental monitoring in air environments. So these are sensors that are meant to be placed or indoor or outdoors, but that can measure parameters in related to air. And to the right side, we have the PM sensor, which is a particulate matter sensor, very low cost, from a manufacturer called Plant Tower, which has been reviewed many times by scientific research, and that shows decent and good results for low-cost sensors. Of course, all of these sensors and everything that we present here has its limitation, being considered as low-cost sensors, but the performance of these, and we consider that is good enough for a low budget. So all this is what we call the Smart Citizen kit. Of course, there's extra things like an SD card, a battery, some USB cables, and a charger, but this is what we would call the basic. Let me go through the different items, and we will see in each of them the particularities. So the data board is basically, as I was saying, the board that takes care of the data collection and is used to interact with sensors. So the sensor board that was presented in the previous slide is connected to the data board through this port here on the left. And then additional sensors, such as, for instance, CO2, or analog sensors that measure chemical composition, such as CO, NO2, or other water sensors, even a GPS, can be connected through what we call this auxiliary port, which is a growth port with 4 pins. That is, let's say, a little bit more advanced, but we provide as already off-the-shelf solution from FabLab. The urban board, the data board handles as well the user interaction. So it has 2 buttons, one that we call the on-off button. We will see what it does later on, but it's basically the main point for us to interact with the kit. And then a small reset button that is a little bit hidden, but with the idea that we will use for debugging purposes. So in case that the sensor is blocked, or that we have seen any problem with the sensor that is not logging data, this will be the first entry point for us to just reset the sensor, hit that button, and then the sensor will start over its process again. There's also some indication for the user. So in this board, and of course, all these items are exposed to outside of an enclosure, as we will see later on. But this user feedback is presented through 2 LEDs. The status LED is this big one LED that shows in which state the Smart Citizen kit is at. So it's either measuring or not, do we have battery or not. We will see the details in the next slides. And then there's 2 other small LEDs that are more meant for development or debugging purposes, but that also indicate or give us some information. For instance, whether or not there's some messages on the USB port, or whether we have Wi-Fi connectivity on these 2 LEDs on the bottom left. Finally, well, this board does a lot of stuff. It also has a micro USB connector. It's micro USB compliant. So is any standard micro USB charger with a cable will suffice for charging the Smart Citizen kit. And then it also has a LiPo battery connector, so a lithium battery that by default is 2000 milliamps, but it can be larger, up to 8000 milliamps. And the device handles the charge or or the measuring of the battery levels automatically. And finally, it records the data, and it also sends data to the platform or stores it in the onboard SD card. So it has a micro SD card slot that can accept up to 16 gigabytes of memory, which will basically be a lot of years of data stored on the SD card. And the Wi-Fi antenna, that we see that it has its limitations later on. There's certain types of network that we cannot connect to, but basically this allows us to send the data over to the platform. Moving on to the next item, here we have the urban board. So the urban board is a collection of sensors that is present in any smart citizen kit that measures air quality or air-related metrics. It has a selection of sensors that are well reviewed in literature that go from air temperature, humidity, noise levels with quite an advanced noise level processing, giving data in different scales adapted to the human hearing, ambient light, barometric pressure, and then a sensor that is meant to measure a proxy for volatile organic compounds, which is normally an indoor air quality proxy. This sensor also yields another metric, which is called equivalent carbon dioxide, which is not CO2. It's not what we understand by carbon dioxide, is an equivalent metric that is derived from the volatile organic compounds one. These two are, as I was saying, from the same sensor, and is of course a very low cost sensor, so it also has its limitation, and we should take these metrics as indication of indoor air quality, but we shouldn't take them in an absolute sense, because it's a very tricky sensor to calibrate and process data from. Finally, and even if it's not shown in the picture, this board also offers a connector to what we call the PM sensor, or particulate matter sensor, that measures PM1, PM2.5, and PM10 based on this plant hour PMS 5003. This has been also very well reviewed, and in our case, we have also conducted laboratory evaluation for the sensor, and we have seen that the sensor performs well in the lower range. So PM1 and PM2.5 metrics are decent to good values, PM10 not so good. And it also depends on the type of particles that we are measuring. But it is a very good sensor that has been also reviewed in terms of calibration and correction. And a lot of people are using it in various different projects as well. So for more advanced configurations, we also have this auxiliary port, and this is in this particular case, this is where other sensors are connected to. So in the air quality field, we connect here, for instance, a CO2 sensor, or chemical composition sensors like carbon monoxide, nitrogen dioxide, etc., etc. Also, some external probes or a GPS can be connected here. And in the case of water quality metrics, this port is also used for interfacing with electronics that measure water quality, and other things such as, for instance, an OLED display to show the readings, or even some graphs on the Smart Citizen Kit can be attached to this port. Finally, before moving on to the next session on understanding the different user interactions, let's talk a little bit about power. So the device can be powered via micro USB. It's USB compliant, so it uses 5 volts DC, and it can be charged with a normal charger, phone charger of 2 amps. It would be sufficient. It can also use more complex power supply, for instance, if we want to deploy it outdoors, such as in the picture above. This would be the setup we will go through in case that we need to install the sensor for long deployments outside, and we need it to be isolated from weather and preventing water to come inside into a dangerous, electrically dangerous or risky part of the sensor. And it also can be charged with a solar panel. So depending on where you're at, a different solar panel size will apply, but it can also be used for charging the device. Finally, as we were saying earlier, if you need to use the sensor with without the USB power, it's also possible. The sensor can be powered with a small lithium battery that can last with the default settings between 3 or 4 days. With more sensors or different reading intervals, it can last more or less. It's not a solution for long-term deployments, so it's meant for short-term deployments, such as I was saying earlier, like 2 or 3 days, but more for long-term deployments. We would be using one of the solutions above, so permanently connecting the sensor either to a USB power supply or a power supply that as the ones that we see here. And again, the duration of the sensor, of the battery, sorry, depends on what sensors are enabled, how often do we read them, and how often do we publish the data to the platform.